let's first understand the question. Given an array of positive integers nums, remove the smallest subarray, possibly empty, such that the sum of the remaining elements is divisible by p. It is not allowed to remove the whole array. Return the length of the smallest subarray that you need to remove, or -1 if it is impossible. So what they are saying is, you are given this array 6, 3, 5 and 2 and a number p that is 9. You need to check whether the sum of this array's elements is divisible by p. If it is not, then you need to remove the minimum subarray. That means minimum length subarray has to be removed such that the sum of the remaining elements of this array is divisible by p. Now, two things that you have to keep in mind over here is that we need to find the minimum length and it should be a subarray. Subarray meaning contiguous part of the array. So, for example, here 6 and 3 is a subarray, 3, 5, 2 is a subarray, 3 is a subarray, but this 6 and 2 is not a subarray because they are not contiguous in the array. So, we need to find a subarray with the minimum length such that if we remove this subarray, then the sum of remaining elements is divisible by p, right? Now, if you see here, in this case, I'll just remove all this. Yeah. So, here the sum is 6 plus 3, 9, 9 plus 5, 14 and 14 plus 2, 16. So, our sum is 16. Now, if I'll do modulus of 16 with 9, I'll get 7. Why? Because this 16 is not divisible by 9. So here it is indicating that okay, we need to remove some x length subarray so that we get what is required. So here if you see 7 is the remaining remainder that has to be removed. Meaning, let's suppose if I want that okay, my remaining numbers should have sum divisible by p. So if I find a subarray whose elements sum is equal to this 7 modulus p, then I can say that okay, this is the subarray that can be removed from my array, right? So here if you see, we are dealing with the sum and we are having subarray. We need to find a subarray. So whenever we deal with subarray and sums, there is 90 to 95% chance that we will use prefix sum for this, that the question will get solved with prefix sum. So prefix sum is nothing but the cumulative sum of the array elements up to a certain index in the array. So if I say that this was my array 6, 3, 5 and 2, I'll write it here 6, 3, 5, 2. Now if I create its prefix sum array, what it will look like? Here we have 6, this sum is 6 here, till this point the sum is 6. So we'll write 6 here. Now if we come at next element which is 3, till here what is the sum? 6 plus 3, that is 9. Then here what is the sum? 9 plus 5, that is 14. Then what is the sum here? 14 plus 2, 16. Right? So this will be a prefix sum array. Now in our question, it is given that the numbers inside this array elements can be too large. So in that case, when you will be doing your prefix sum, your integer might overflow. So whenever we are calculating this prefix sum, we'll keep on doing the modulus of our sum with p. So this array will actually look like, so we'll do 6 modulo 9 which will give us 6, 9 modulo 9 which will give me 0, 14 modulo 9 will give me 5 and 16 modulo 9 will give me 7. So this is what my prefix sum array will look like, 6, 0, 5, 7. Now if I say you that you have this prefix sum and you want to find out that what is the sum of elements of a subarray which is in this range I and j. So how will you calculate with the help of this prefix sum array? So what you will do, if you do a of j minus a of I, right? So is this going to give me the sum of the elements of the subarray in the range I and j? Let's check. If my I is, I'll give the indexes here 0, 1, 2 and 3. So if my I is 1 and j is 3, so it will be a of 3 minus a of 1, which is 7 minus 0 equals to 7. So this is going to give me this particular subarray's elements sum, right? This I'll get. So this expression will keep in mind that if we want to find the sum of all the elements in a subarray in the range I and j, then we'll do a of j minus a of I, where a is our prefix sum array. Okay, now let's remove this. We were having this original array which was 6, 3, 5 and 2. We have the total sum of this array, right? We have the total sum. Let's suppose I'm denoting it with variable sum. Now in this, if what I was supposed to do, I wanted to find the minimum length subarray whose sum, if I remove from the total sum, then the remaining elements sum will be divisible by p, right? So here, if let's suppose this is that subarray, this is the index I and this is the index j, so we'll do a of j minus a of I, right? If I subtract this from my sum, the total sum of the array, and then when I do its modulo with p, then it should be equals to 0. Meaning whatever subarray I will found, what will be the formula for calculating the sum of this subarray's elements? A of j minus a of I, and the total sum of my array is sum. So if I deduct this subarray's sum from my total sum and then I do its modulo with p, then it should be equals to 0. This is what we have to achieve. So we can break down our problem to this equation. Now can I write this? Can I take a of j with sum and we'll keep a of I here. So this minus minus will become plus. So our equation will become like this. Sum of sum minus a of j together plus a of I modulo p equals to 0. So now we know that if somewhere it is written that x1 plus minus x2 modulo p, then we can write it like this: x1 modulo p plus minus x2 modulo p and then whole modulo p, right, with the distributive property. So here also it will be sum minus a of j modulo p plus a of I modulo p whole modulo p equals to 0. Now what we'll do is we'll take this expression on the right hand side. So what it will become? ai modulo p equals to a of j minus sum modulo p, right? Now when we were calculating our prefix sum array, we already did the modulus with p for all the elements. So can we write it like this, a of I? Because a of I is already done modulo with p, and if we'll do again, we'll get the same answer, right? So a of I will be equals to a of j minus sum modulo p. Now there might be a case where this expression a of j minus sum will give you a negative number, right? So negative number when done modulo with p will again give me a negative number. And this a of I was what? This was sum, right? Can sum be negative? No, right? So this has to be handled somehow. Now we know that this aj, we have already done the modulus of all our prefix sum elements with p, right? So this a of j will be less than p because we have done its modulus. And then this sum, when we were calculating, then also we had already done its modulus with p. So this sum will also be less than p, right? So if I do a of I equals to a of j minus sum and then I add p here and then I'll do its modulo with p, then we can say that this expression will never be negative now. It will always give me a positive number. So now we have reduced our equation to this. So let's remove everything and we'll write this here. So it was a of I equals to a of j minus sum plus p modulo p, right? Now what we have to do is, we have to find all those subarrays within this range j and I where we are having this value. Okay, so let's suppose I have got this value as 2. Now there was some another index at which we have already found the value of this expression as 2. Then that means that will be my ith index and this will be my jth index, and this is the subarray that I am looking for, right? So at every index, at every element in my array, I will calculate this expression's value, and whatever is the value, I'll store that in a map. I'm taking a map here. In the key, I will store the expression's value, whatever it will come out to be, and in the value I will store the index. So let's suppose I was at index 0 and the expression value was 2. So I will store 2 here and 0 here, right? So that whenever I will encounter any value again, I can simply check in my map that okay, I have already encountered this. So I will be able to check that whether this is a valid subarray that I am looking for or not without so much of computation, right? So if in case, so this expression give me 2 and 2 was already present in the map, then that means this is the subarray I am looking for. So I know the index here, whatever is my current index here when I have calculated this value, and whatever index we have stored in our map. So whatever will be their difference, this will be the length of that subarray, right? And since we need to return the minimum length subarray, so we will keep on updating a variable with the minimum value of the length, and at the end whatever will be the value of that variable, that will be our answer, right? So now let's move on to the code. So first of all, what I'll do, I'll create a variable n and take the size of my array in this nums.size. Then we'll find the sum of array. So we'll take int sum equals to 0. Now we'll iterate in our array nums and we'll find the sum. So sum equals to sum plus num modulo p. I told, right? So whenever you are calculating the sum, at that time itself we'll do modulo p because the array elements can be very large. So now what will be a target? Target equals to sum modulo p. This is what we will look for. Now if my target is already 0, meaning the sum of the array, the sum of the elements of my original array are already divisible by p. The remainder was already 0. That means I do not have to remove any elements, right? So in that case, we'll simply return 0, right? Otherwise, we'll create a map, as I said, of int comma int mp. Now initially, we'll put mp of 0 equals to minus 1. Now why are we doing this? Why we are keeping minus 1 at index 0? So now if you see here, so this was my array 6, 3, 5, 2. Now let's suppose these are the indexes 0, 1, 2, 3. Now I got 2 here, the expression value, and here also I got 2. Just let's suppose, right? Now here, if you will see their indexes, it is 1 and 0. If I'll do 1 minus 0, it will give me 1. But my subarray length was 2, right? So this will give me wrong result. So to handle that case, I need to create a boundary over here. To handle that case, in my map initially I will keep 0 and minus 1. So whenever you will do this, so what it will do? 1 minus minus of minus 1. So it will give 1 plus 1, which will equals to 2. So that is 2 array elements. So that's why initially we are keeping mp of 0 equals to minus 1. Then we'll take a variable current sum, which will be equals to 0, and a mini variable to keep the track of minimum length subarray. Now we'll loop from int I equals to 0, I less than n, I plus plus. Then we'll calculate the prefix sum. So cur will be equals to cur plus nums of I modulo p. So as we did here, that first we calculated the sum, then we did modulus with p. So that's what we are doing here. First we calculated the sum, we added current sum with nums of I, and then we did modulo p. Now we'll calculate the value of our expression. So int x equals to cur minus target plus p modulo p. So this is my expression's value. Now I will find whether this value is already present in my map. So I'll do if mp.find x is not equals to mp.n. So this means that the x element is already present. So when it is already present, I will update this mini length variable. So mini equals to min of mini comma I minus mp of x, right? And every time I will update my map. In the key, I'll store the sum, the current sum, and the value I'll store the index. Now, at the end, what we'll do is, we cannot simply return mini. Why? Because in the cases where you cannot achieve the desired result, it is impossible to find such an array. In that case, our mini will have this value n, which was the initial value. So in that case, we need to return -1. So while doing this, we'll check that if mini is equals to n, then return -1, otherwise return mini. So now let's run this. So in this case, we are just looping in our array once, which is given to us, and here also, right? So our time complexity will be big O of n. So as we see that the test cases are accepted, let's submit it. It got accepted. Thank you so much for watching.